Okay, guys, so basically what we're going to start doing now are examples. So let's start with example 1. Okay, so from our previous video, we made the idea that y equals mx plus b. Well, what did we say that m was equal to? We said that m was equal to y2 minus y1 over x2 minus x1. So these are equivalent statements. I hope you can at least see that. So basically what I want to start doing is just, a few more examples. I won't do a lot of them, but I'll probably do this one and one other. Yeah, so let's say, we had a graph, right? And we know that, let's see. Hold on. Whoop. Okay, here we go. So let's say we have a graph right there. Good old Cartesian plane. We're going to say bye to you soon. Okay, so basically, let's say we had some sort of line and it crosses there at, I don't know, what's a good number for today? I don't know. Let's say it crosses at 0.18. That seems like a thing. So let's say it crosses at 0.18, okay? And we know that, it will come up to, let's say this is like 327. Yeah, that seems good. Okay, so let's say it goes to 327, right? That will be this point, and that will be that point, okay? So we want to figure out, the slope of this line. So what would we do here? Well, right, what we want to do, or the perspective that we want to take, is that we want to figure out the slope of this line, like before, and we want to figure out the y-intercept, right? So what would we do here? Basically what we do here is it's the same idea. We have this idea, y equals mx plus b, right? And y equals y2 minus y1 over x2 minus x1. That's equal to m, right? So basically what we do is we just substitute here, right? So what did we say? So this will be equal to 27 minus 18 all over 3 minus 0. So wow, that actually I did not I did not do that on purpose, but okay. So we know that these are equal statements, right? So what do we get here? We get that this will be equivalent to basically 3. Yeah. So basically 3x plus b. That's what we have right now, right? We know that this is equal to 3x plus b because, right, 27 minus 18 is 9, and then you divide by 3, which is 3, so we know that our m is 3. Now, what's the difference here? That is the difference from last time. Well, our linear guy crosses the y-axis at 0.18 instead of 0.0. So how would we figure out what our b value is at this guy? So we know that at 0 the output is at 18, right? So we know that y equals 3. Whoopsie. We know that 18 equals 3 times 0 plus b, right? You just plugged in your x value, and this was the y value that we expect to get, 18. So from doing this, you see that b equals 18. So what do we get from that? We basically get that we can write the equation of this line. So we know that the equation of this line is y equals 3x plus 18. So, and how can we check this? Well, we have a point on this line, 0, 18. So we know that, you know, at x equals 0, then y has to be 18. Well, 18 equals 18, right? So also, another thing is that when we plug in 3 here, right, we get 3 times 3 plus 18, right? So 9 plus 18 is 27. Well, our output there is 27, so 27 equals 27. So let me just write that out for people who don't readily see that. So 27, does that equal, and this is how we kind of represent in mathematics if we're trying to like prove some sort of identity, you know, the equals with like a question mark through it. So is that equal to 3 times 3 plus 18? Is 27 equal to 9 plus 18? Is 27 equal to 27? Well, it sure is. So looks like we proved that identity. So yeah, that's going to be example 1 of basically calculating equations of linear lines. The basic idea is you just find out your slope, and then from your slope you just plug in a point on the line to basically, you know, figure out what your y-intercept is. You know, specifically usually if you plug in the value of x equals 0, because this is where your x is 0, that will basically be what your b value would be. Because, you know, there's a reason why they call it the y-intercept, because it's the value that when x is 0, the line passes through the specific y point. So yeah, that's going to be my video for right now. Stay tuned for example 2.